Hello and welcome back to the channel Understanding Concepts of Physics. We are here to discuss another doubt question of one of my student who has personally asked me this doubt. This is a question on current electricity, and I would suggest you to go through this question into very detailed, as there are certain rulings in options. I hope you might have gone through this question. Let's go ahead and work out this one. Now, if you can see the statement 1 says that these two circuits are same. This is the first statement. In order to find out current, we can connect this circuit as good as this. That's first statement. And second statement says that the R1 and R2 can be connected into parallel if the potential difference across them is same. So let's go ahead, let's see. Now here I would like to make you assume certain things in order to get the question right. Let's assume that this is a point where all the three resistors meet is at a 0.5 volts. So let's say this is 0.5 volts. Of course, this is the same point where all the three resistors meet, and that is also 0.5 volts. Now, I am also making you assume that this is the point at which 1.5 volts is present, and I can say that this point is also 1.5 volts. The reason being, the EMFs at this point and this point is same. So if here it was 2 volts, it would have been 2 volts here as well. Here it would have been 10 volts, here it would have been 10 volts as well. But this is a common point, so all the resistors will have this point, this region, this wire will have the same potential, 0.5. So what is the potential difference between these 2 points? The answer would be 1 volt. And the reason is, it's a potential difference, the difference in the potential. 1.5 minus 0.5, that would be 1 volt. Same way, 1.5 minus 0.5, this would be 1 volt. So this is 1 volt as well as this is 1 volt. So if you see, R1 and R2 both have a potential difference of 1 volt. So, and you check this one. If this is 1.5 volts EMF and this is also 1.5 volts EMF, so at this point it will also be 1.5 volts and not 3 volts because EMFs, when you have EMFs in parallel, this EMF is 1.5, this is 1.5, so you will get an effective voltage between these two as 1.5 volts itself and not 3 volts. You will get a 3 volts potential difference only when you connect them in series. So now I will have a 3 volt ka potential difference between these 2 points if this is 1.5 and this is 1.5. So in series your EMFs add up. Now in this case, these EMFs are in parallel to each other. So if this was 1.5 and this is 1.5, this point, this common point will also be 1.5. So I'll mark this with a pen. This is 1.5. So if you see, this resistor R1 and this R2, they both have a potential difference of 1 volt. That is 1.5 minus 0.5. That is a 1 volt. So the answer is yes, you can connect this into the circuit because you are not changing the potential difference on a particular resistor. Even here R1 has 1 volt, even here R2 has 1 volt. Same it goes for R1 and R2 here as well. So since you are not changing it, the circuit is as good as same. And second, so first statement is correct. Now the second statement says that whenever the potential difference across two resistors is same, which is correct. Both resistors can be assumed as a combination of two resistors in parallel. Now if you see, this is what it is actually happening here. The potential difference was 1, potential difference was 1, potential was 1, potential was 1, and these two resistances were not in parallel in this circuit. But in this circuit, you will see that these two resistances are in parallel connection. So whenever the potential difference across two resistors are same, you can definitely connect them in parallel. And so statement 1 and statement 2 both are correct, and actually statement 2 is basically the statement 1 is the result of statement 2. Like, because this rule is applicable, statement 1 is true as well. So it is correct statement. It is second is also correct, and second is actually the correct explanation of the first one. So the correct option would be option A. So A would be the correct answer. In case if you have followed this, like and subscribe to the channel. Thank you so much for watching.